Hello guys, welcome to Programming 9 C Programming video tutorials. In today's session, we are going to discuss one of the very important basic building block in C is operators. Let us see what is an operator and how we use these operators in C programming language. How it is actually fetching for us. Simply, an operator is a symbol that tells the computer to perform certain mathematical or logical manipulations. Right. Sometimes we need to perform some mathematical operations like addition, subtraction, multiplication and division, likewise operators, or some logical manipulations like shifting of bits from left to right, and these operators are used to perform some manipulations on data or variables. Of course, C has very rich set of operators. We have already used several of them from our childhood like addition, subtraction, multiplications, divisions, etc. But what we have to do here is let us categorize them into different parts or different classifications. Let us see what are those. Types of operators are arithmetic, relational, logical, assignment, increment and decrement, conditional, bitwise and special operators. Generally, these are the 8 types of operators that we can find in C programming language. Let us discuss each of them. Arithmetic operators. Arithmetic operators are used to perform numerical calculations among the values. Right? Just like addition, subtraction, multiplication, division or modulo division. Right? What are these? I think no need of an introduction about these operators. Just like addition, which is used to add to values, subtraction used to perform the subtraction operation, used to multiply, used to divide, and here the modulo division. Modulo division means remainder of two values. I just have written a program using arithmetic operators. I've just taken some of the variables and I'm reading two values of a and b here. I am performing addition operation, subtraction operation, multiplication operation, division and modulo division. Right? Result of the addition is I'm just printing these values. I'm executing this. If you see it clearly, the percentage symbol are called as modulo operator. This can be used only with integers. It cannot be applicable to any other data types in C, like float, char. We cannot apply for those. Enter A and B. I've taken two values 25 and 5. Let us see now. Result of the addition is 30. Result of subtraction is 20. Result of multiplication is 125. Result of division is 5. And of course the remainder is 0. Why? Because 25 by 5 equal to, actually the result is 5 but the remainder is 0. So modulo is used to find out the remainder of a calculation. This is a simple example what we discussed now. Relational operators. Relational operators are generally used to compare two quantities and take certain decision depending upon their relation. Generally, we have seen less than or equal to, greater than or equal to, or not equal to. These are the operators come under this relational operators. If the relation is true, it returns 1. If the relation is false, it returns 0. A simple example to this is, if I taken into values a and b as 10 and b value is, assume it as 5. So if I compare this with a is 10, b is 5, 10 less than 5, the condition is definitely false. So it returns 0. Here if you see less than or equal to b, condition is fail. So it returns 0. A greater than b, absolutely right, it returns 1. A greater than or equal to b, it also returns 1. A equal to b. If this is a very important concept in C programming, like whether we need to use double equal to or single equal to. Single equal means it should be assigning some value to some variable. But here it is comparing a and b. That is whether a is equal to b or not. No, here 10 is not equal to 5. So definitely it is false. So it returns a value 0. If you see a not equal to b, absolutely right, because a is 10, b is 5. Let us execute this program. A less than B, less than or equal to B, greater than B, greater than or equal to B, double equal to. Simply remember it, comparison operator, and not equal to. Let us execute this code. Let us read the two values. Like I'm just taking what I have taken now, 10 space 5. I've read two values. Less than 0, 0, 1, 1, 0, 1. These are the values. It only prints either 0 or 1. Next, logical operators. These operators are used for testing more than one condition and make a decision according to that way. Generally, three kinds of operators we will see in logical. That is, logical AND, logical OR, logical NOT. So, here the logical AND means, if you see the simple example, I have A value 10, B value 20. Just consider A is 10, B is 20. Now see this entire relation or see this entire statement, A less than B, that is 10 less than 20. Here we are performing some logical AND operation, and A is 10 not equals to 20. See this entire relation. 10 less than 20. The condition is true or false. Let us check them first. See, 10 less than 20. The condition is true. So, the left part is 1. And here we are performing some AND operation here. So, logical AND. So, if this condition is true, then only it will jump to the next condition, that is 10 not equals to 20. This is also true. So it also returns 1. 1 and 1 returns 1. So it prints a value of 1. Similarly, if you see A less than B or B less than A, here both conditions should satisfy, that is this one should be 1 and this one should be 1, then only the equation will be valid one, and it returns a value of 1. Here A less than B or B less than A, either of the condition must be true, that is either maybe first condition 1 or the second condition 1, it returns a value of 1. So if you see it clearly, the first statement 10 less than 20, if it is in case 10 greater than 20, the condition failed here. So it gives a value of 0. And here you need to remember one thing. If the first condition is 0, it don't go to the second condition because it's no need. Similarly, this one. If the first condition is true, it doesn't go to the second condition because that's not needed at this point. If the first condition failed, then it will jump to the second condition for checking whether this is 1 or 0. Next one is A equals to B. I told you about this. A equals to B means 10 equals to B. It's comparing both A value and B value. 10 not equals to 20. So the condition is failed here. We can say A equals to B. It returns a value of 0. Not 0 means 1. Next operators are assignment operators. These operators are generally used for assigning the result of an expression to a particular variable. Just what we discussed in the previous point, like double equals to and equals to. If you see B equals to A, it means whatever it may be the value existing in B will be transmitted to the variable B. This is quite simple. We can use this assignment operator with addition, subtraction, multiplication, division, modulo division, left shift, right shift, etc. Let us see the simple example to this. C plus equals to B, C minus equals to A. It means C plus equals to B means C equal to C plus B. Here C equals to C minus A, C equal to C into A. Like that, we are forming very short definitions for that. An assignment operator is simply equals to. We add some of the operators along with this assignment operator. But only one thing you need to remember here is whatever it may be the calculation on the right side of the equal, will be assigned to the left part of that equation. And increment and decrement operators. These are the two most useful operators in C. As we seen, plus is for addition, minus is for subtraction. If you mention double plus and double minus, this indicates that increment or decrement. So plus plus means it adds 1 to the existing value, minus minus means it subtracts 1 from the existing value. That is, a equals to a plus 1 or a plus plus. These two are same. A minus minus or a equals to a minus 1. These two are same. These operators are very useful in certain situations in C programming. We might see about these operators in later classes. This is the simple example of increment and decrement operators. Here, this is called pre-increment, this is called post-increment. Here, this is called pre-decrement and this is called post-decrement. If you assume a value is 5 here, first it increments a value to 6 and then assign it to the C. So, a value is 5 here. So, plus 5 is 6. And then the entire value will be passed to the C. Now if you see C equal to a plus plus, this is post increment. So that first it assigns a value to the C and then the value will be incremented. But if you see here C equals to minus minus B, what does this mean is, first it decrements a value and then that will be passed to the C. If you see here B minus minus, that is post decrement. The B value will be assigned to the C first and then the value will be decremented. Don't worry, we will see examples at the end of this session. Next, conditional operators. These conditional operators are used to construct conditional expressions of the form expression 1 question mark, expression 2 colon and expression 3. This is called a ternary operator. Expression 1 question mark, expression 2 colon, expression 3 here. If the expression 1 is true, it will jump to the first part. If the expression is false, it will jump to the second part. See the simple example here. If A greater than B, assume A is 10, B is 20. The condition failed. So, it will be passed to the B. What we have in the B? 20 we discussed. A is 10, B is 20. So, 10 greater than 20. Condition failed. So, if the condition is true, A will be executed. If condition is false, B will be printed. Like, here the condition is failed. So, B value will be assigned to the X. So, here the X value will be 20. Bitwise operators. These operators deeply work on bit level. And of course, these must be applied to integers only. It doesn't affect anything with the real values. Bitwise AND. Simply remember, AND is just like a multiplication, R is just like an addition. See, we have left and right. Two conditions are two expressions are there. In between those expressions, we must have to implement all these operators like 0 and 0. It gives the value of 0. Similarly, 0 and 1, it gives a value of 0. I told you, just keep it, remember, this AND is simply indicates a multiplication type of operation. That is 1 and 0 means 0, and the last one is 1 and 1 means it gives you 1. That is, it should have a left expression or left value or left variable and some right variable. If you perform this operation, if these two satisfies, it gives the appropriate value at the end. Like bitwise R, this is quite opposite. 0 or 0 means it's just like an addition. So 0 or 0 means 0, 0 or 1 means 1, 1 or 0 means 1, 1 and 1 or 1 means 1 itself. Bitwise exclusive OR, this is a little bit different. So exclusive OR means either 0 0 or 1 1. At these two situations it gives a value of 1 1, and the remaining these two conditions it gives a value of 0. Next, two more very important things are shift left and shift right. What is shift left? Let us see it. To understand about the shift left and shift right bitwise operators, we should have to know about the memory system of a computer. But let us see the simple example of this. Let us take a memory block here. I am taking a memory block of 8 bits. Assume this is from 0 to 7. 0, 1, 2, 3, 4, 5, 6, and then at the end it is 7. So we have a value of 2, just assume. Here the 2 means 0, 1, and the remaining all fields fill with zeros. How I got 2? Simply in the memory system, if you consider a value of 2, it means 2 power 0, 2 power 1, 2 square, 2 cube, etc. What is this? 2 power 0 means it's a 1. So this position is 1. 2 power 1, its position is 2, 4, 8, 16, 32, etc. If you want to get a value of 10, so here this 0 will become 1 because 8 plus 2, 10. If you want value of 12, so 1, 1, these two are becomes zeros. All these left side bits are zeros. If you want a value of 32, so this 32 bit position should be activated as 1 and the remaining all bit positions becomes 0. If you want to get a value of 15, now what we have to do? 8 is 1, 4 is 1, 2 is 1 and 1 is also 1. The remaining all left side 4 bits becomes zeros. This is the way of assigning a value here. 2 means 2 power 1, this means 2. So this bit must be activated as 1 and remaining all can be zeros. If you take a simple example of 2 left shift 2. So 2 left shift 2. This means all the bit positions must be moved from right to left position. That is, again I am taking the same block, assume 1, 2, 3, 4, 5, 6, 7 and 8 here. So 0 to 7. Now the 0, everything will be moved one position to the left. That is, this bit position will comes to this position. Similarly, this bit position will comes to this position. Similarly, this one, this one, this one, and this one. Automatically, the right bit positions are empty. So we have to fill them with 0, 0. Now forward each and everything. 0, 1, 0. Just replace with the same fields. What about these two? Just ignored. This is called a left shift. If you want to perform a right shift operation like 2 right shift 2, it means all the values will be moved to the right side rather than the left side. Now what is the value of this? We already seen this is 2 power 0, 2 power 1, 2 power 2, this is 2 power 3. Now the value here is 8. just like 1, 2, 4, 8. So if you perform this left shift operation, the 2 value becomes 8 here. Right, that's about the bitwise operators. And then the last one is special operators. C supports some special operators such as comma operator, size of operator, and pointer operators. Generally, you might see comma operator and size of operator. Here the comma operator are generally used to combine the related expressions. Just like value equals to x equals to 10, y equals to 5, comma x plus y. It reads a value of x and read a value of y and then perform the sum operation as 10. So the 10 will be passed to the value. Next, the size of operator. Size of is an operator used to find the size of an operand. For example, size of sum means sum is a variable. This variable may be integer, may be float. If it is an integer, it returns a value of 2, that is in the form of bytes. That is the thing we need to remember here. So size of sum is 2 bytes. So m occupies 2 bytes. That is some m indicates 2 bytes. So size of 2351. It's simply an integer value. So it also occupies 2 bytes of memory here. So the size of operator is most important to find out the sizes of different variables existing in your program. Thank you. If you like it, please like us at facebook.com/programming9. Right, let us execute some of the programs that what we have seen in the presentation. First, I am selecting increment and decrement operators because these operators are something special and of course little bit confusing. See here, C equals to plus plus A. I told you this is a pre-increment. A plus plus means post-increment operation. Similarly, pre-decrement and post-decrement. Let us see the fun here. A and B, I am taking A as 10 and B as 20. See the output. The value of C is 11. That means initially A is 10. So first it is incremented and then the value will be passed to the C. Now so that C printed as a 11. If you see it here, C equals to A plus plus. That means what we have in A already 11. Now the 11 is directly assigned to the C and then the value will be incremented. If you in the next line, if you print it again, it gives, let us test it with a simple example. I am saving it and executing the code. Now what it is giving? 10 space 20. 11, 11, 13. Now I think you got it. So if you write something prior to that operator, it means it first assigns to a variable and then the value will be incremented in the memory, just like the decrement operators. Similarly, the logical operation, logical and logical or logical not. Let us execute this code. I already told you this is simply a short circuit form. That is A is 10, B is 20. It written 1, 1, 1 because A less than B. That means 10 less than 20. The condition is true here. So 1 and A not equals to B. Condition is true. 1 and 1. It gives a value of 1. A less than B or B less than A. A less than B means 10 less than 20. The condition is true. So whenever the condition is true, it don't go to the next condition. So it completely eliminates the right part. Simply it considers the left part.